Righto, good morning everyone. Sorry for the bit of a late start for obvious reasons. Thanks everyone for turning out in this. It's pretty horrible weather and I know everyone probably got wet getting in, so much appreciated. So hopefully Monday's lecture will have started to at least get you thinking about the way that you're phrasing and writing and using sentence structure in these reports or this report that you're writing. The briefs that you've been putting together are just that, they're briefs, and they probably don't contain a lot of good quality writing. When you lace them together, you will need to incorporate some decent sentence structure and maybe improve some of the comments and sentences you've used to describe things throughout those briefs, such that when it's a report, it stands alone as a good quality design report. Okay? Now, the writing in that is very important, and the other aspect of written communication that is critical, in my opinion, is the visual aids. So the images, the tables, the graphs, how do you actually put those or format those for a good quality design report? And that's what we're going to talk about today. Now, obviously, if we identify our learning outcomes Monday and today are squarely in the appropriate and competent use of written, oral and pictorial communication skills. So largely written, but we'll be talking about pictorial stuff today. So this is a major outcome of this subject, and so hopefully by the end of this subject you'll have a bit of an idea of how to write a design report, and then you'll have another 3.5 years to keep practicing it. All right, so first I'm going to talk about figures. Now, figures, it's a picture, right? Everyone knows how to put a picture into a document, but what I want you to start thinking about is what purpose does that picture serve and how much information can you fit in that picture? Reason being is a really, really good figure will save you pages of writing, which isn't so much of a concern at the moment, but when you get to the sorts of things I was talking about, your 3-page design brief that you're handing to a client, then you want every single figure in that to tell many more than just one sort of data point or one bit of information. You want those figures to be really dense and good quality figures, okay? So what you need to do right from the word go is start thinking about, all right, well, I've got this image here. What can I do to that image to actually enhance it or tell more of a story, because that's going to save me the writing. Make sure that you use clear images, so pixel size is important. You don't want a really horrible pixelated image going in a report. And when we're actually doing this type of thing, you want labels and arrows and explanatory text in the actual figure. And make sure you're consistent with your naming. I know sometimes you make a bunch of figures and then you go and write a report and you change the way, the wording or the descriptors that you're using. You need to go back and change those in the figures if they're there. I honestly, for some of the research papers I've written, I've sat down and spent a day to a day and a half drawing a good quality figure. Yeah? So you can spend a lot of time doing a good quality figure. You probably spend the same amount of time writing if you didn't have that figure. And the benefit of the figure is someone actually brushes through your report, they hit it, they see it, they get all of that information. We are very visual, so if we see a picture, we can absorb a lot of that information. You can't look at a paragraph without reading it and absorb that information unless you put big bold text around a critical stress or something like that. So images are really useful. This is an example from Rockfield Technologies. Has anyone heard of Rockfield? So Rockfield are a consultancy firm. They have mechanical engineers and civil engineers. And they're right on the sort of bespoke end of consultancy. So where AECOM and these guys do a lot of the big GHD and so forth, big design stuff. If you've got something that is a little bit different, a little bit more complex, if you want to have a particle hopper out in the port and actually simulate that and work out how to optimize it, Rockfield are the ones you go to. This example is a rubber, what is it? It's basically a steel bracket that a rail for a railway line goes through, and then you have a rubber basically buffer under it, all right? And they were finding that these were failing, and so Rockfield did an analysis of it. And you can see in this figure, there's a lot more than just a single contour plot. Has everyone seen a contour plot before? So a contour plot is basically where you have the components, and if you want to know something like stress, so oftentimes stress is the reason things fail, so high stress means it'll crack there. So you'll have the very high stress is red and the very low stress is blue, and the rainbow between there tells you what stresses are at different places throughout that item. So if you look at the top one there, you can see the red, that 259 megapascals, is right in that corner there. Okay, so already that's telling us a lot, that that's where the critical zone is, that's where it's likely to fail. But they haven't stopped there with this figure, right? So they've got that, but then they've gone, all right, what else might we want to know? We might want to have a look at the section through there and actually see, because at the moment, the top one, all you can see is the outside surface. And something more critical might be happening on the inside of that item. So they've shown you the second picture down in white. They've shown you where the actual section is, and then they've pulled it out down the bottom there, and they've got the actual section stresses, still the same key. And immediately above that, if my cursor going to show up, this one here, that's the actual thing. That's the actual item that they've chopped through, and they've got. You can actually, when you're doing condition or when you're doing root cause analysis, you start to understand the different failure modes. And so they know that the crack initiated up here, and this is a crack propagation site, and then this is where it just went bang and broke. Okay, so that crack propagated from that corner down through that item. And so what they're showing is that the stresses that they've calculated, saying, all right, a crack's going to start here and go down, they've got the real item here, demonstrating that that's what's actually happened. And then over here they've got vectors. It might be a bit small to see up there on the screen, but the vectors are the principal stresses, which are showing the direction of the stress. So you guys have done force on your force effects, so some of them tension, some of them compression, some of them you've got bending and things like that. All right, so that's the same thing. So what direction is it being stretched in? Is it being stretched or compressed or whatever? So that's what's there. So in what I've described to you, they would have a paragraph or two saying a similar sort of thing, but you can see the density of information in this plot. It's both telling us broadly in the whole machine component, where's it critical, what does the critical cross-section look like, demonstrating that the analysis that they got is agreeing with the actual experimentation or the failed item that they've been asked to audit. And there's also a couple of other, they've got little bits of text on there showing you, that's fracture surfaces after 1.83 million cycles. So this thing got loaded up 1.83 million times before it broke. So you can see there's so much information in that, and it's going to save you pages of writing to actually explain all of that. And that's where you need to get with your figures. Good quality figures will mean you can communicate something in 3 pages that at the moment you're probably comfortable communicating in 20. All right, so that's what I'm trying to get at today. I've got a couple of examples of high quality figures, just figures that I've used in papers and things before and some other different sources. These figures are telling you a lot of information. This is some research that I do of fluid flow, flowing around ideal porous medium, because then you go to the oil reservoir rock and use the same simulator so you can verify things with this. So in the first one, you've got a cylinder pack and the flow's going across it, and then what we're actually analysing is a little subset of that, and you can see the dimensions and information on it, the direction of flow or force, what radius is. So when I talk about R in the text, I don't need to explain R is the radius of a cylinder that is in this unit cell, and we're only modelling a unit cell part of the whole thing. It's all indicated right there in that figure, all right? And then the second one, we got 3D examples, so you're modelling spheres rather than cylinders and so forth. But you can see how just those explode out little diagrams are great. I love them. The best engineering drawings that I've seen. You see Rockfield are doing it here. They've got this going to that and exploding out to a larger zoomed in zone so you can really see what's going on. That's exactly what I'm trying to do here. Same thing again here. This is some particles in a channel flowing along, and you want to see what the actual particles look like at different times. You blow it out. So rather than have one big figure here, this is the general thing, and one big figure, this is the zoomed in, or only having the zoomed in one, because if you only have the zoomed in one, you don't know where it is or what it actually looks like in general. Having this sort of that magnifying glass idea is really, really good. If you take one thing away from today, it's that if you can look at a drawing and think, I'd really like to have that bit zoomed in, but this bit larger, just do, a circle, and a larger circle version, like a magnifying glass on that picture. It will be really useful, and that makes for a really good engineering drawing, especially if you put a couple of bits of text or something on there. Same thing, you can see this is just an example of putting a lot of dimensions and labels and things like that. So good quality dimensions. You guys can do all of this stuff in SolidWorks now, or at least you will be able to by the end of the semester. So you can actually draw something up in SolidWorks and then drop out a screen dump of that and put it into Photoshop or something and start annotating it, chopping it up. Use it as a solid modelling tool in your figures as well. It would be very useful. Another example, and you can see in each of these captions underneath. So with figures, you always have a caption underneath the image, all right? And it will be figure 1, figure 2, or you can have FIG dot 1, 2, 3, or whatever you want to do, but it has to be figure, the number, and then an explanation of what it is. And you can have an explanation of just what it is in general, square periodic array of infinite cylinders, or you can have model geometry for etc., etc. A, what am I showing in A? Initial configuration, and B after a particular time. So you can have the A and B described down there. Once again, we've got figure down the bottom explaining what's going on. And that is the case again here with a much larger description, but if you put a detailed, good quality description in that caption, then you're removing the need to do a lot of that in the text as well. Okay? So every single figure must have a caption. In your report, every single picture that you put in that report must have a caption, and it must be consistently numbered from start to end. Now, I don't mind if you use 1 at the beginning and you go through to 500 at the end, or whether you use 1.1, 1.2, 1.3 per section, and then section 2 would be 2.1, 2.3, 2.4, etc. That's up to you. But every single figure, drawing, anything that goes in your report must have a caption underneath it. And technically, it's a little bit less important for this one, but basically every design report from here on in, if you don't refer to that figure in the text somewhere, it doesn't deserve to be there. All right? Figures must be referred to in the text because you don't read figures, you read text. And so as I'm reading through the text, the only way I know to look at your figure is that you tell me. So this is shown in figure 6. Right, good. All right, and the next text, all right? If you don't tell me when to look at a figure, I won't look at it. I'll look at it when I brush through, but that figure doesn't deserve to be there if it's not referred to in the text. Now, you don't have to explain exactly, everything that the figure's doing. You can summarise, but you need to refer to it in the text. All right, this is another example. This is as you get further along in your degree, you'll be doing some things like finite elements and simulation work, that kind of stuff. You could very easily, this is a hub shaft for a FSAE car like the motorsports car that we have. You could very easily just have that shaft and show it with those stress contours. But by putting the shadowed upright and wheel housing and everything like that and bearings and things over the top of it, that's showing you that that critical stress is actually lining up with the edge of the bearing. And that edge of the bearing is actually where that shaft's bending against, and that's why that critical stress is there. And so you can talk about it in the text, and you don't have to explain that the critical stress is located at a bearing. You can just say, refer to figure so-and-so, the critical stress is this. Yeah? And so think carefully about the way you structure figures. Also, if you have a contour plot, you absolutely must have the key. Red and blue are meaningless unless I tell you or you tell me what red and blue mean. Okay? All right, any questions on figures? Figures is anything that's a picture, yeah? Anything that you draw or any sort of data that can be pictorially represented. Tables, obviously, are any sort of data that's more efficiently demonstrated like this, all right? More efficiently demonstrated as columns and rows. Tables, again, absolutely must have a caption, always. Table captions generally go at the top. My preference is for table captions to go above the table rather than below, okay? Your table numbering will be different to your figure numbering. So figure 1, 2, 3, table 1, 2, 3, okay? And always remember to use things like units, all right? And it's better to use units in the column headings than all the way along. It just makes it clearer to read. So for example, these densities, I've got kilograms per metre cubed at the top, then I don't need to repeat that for every data entry in the table. Final thing, who likes using Microsoft Word templates for tables? No one? Good. Excellent. That's the right answer. All right? They're rubbish. They look crappy. I suggest you use this formatting for tables. Almost every international journal paper or textbook uses this formatting for tables. Some textbooks use colour because they're doing colour pages and they're trying to make their textbook look interesting to you, but they've got professional graphic designers doing that. They are not using MS Word. Okay? Word tables look really kiddie. They look like sort of, year 9 history reports to me. This is a formal engineering table. So you have a line at the top, you have a line under the headings, and you have a line at the very end. And if you absolutely must, you can have lines separating groupings of data throughout the table. But that's about what you want. In some circumstances, you might have, subheadings, so like group. 1, 2, 3, 4. And in that circumstance, you put a line there and, whatever you... so forth, and line on the bottom. So just a single line. I really don't like vertical lines in tables. You can use them if you have to. I just don't think that they look as professional. This is the standard convention that almost every journal paper in the world uses. So use something similar to that. It's very easy. You just blank the formatting in MS Word, and you just put a border at the top, put a border at the bottom, put a border at the very bottom. Done. Cool? Obviously, if you can't read the table doing that, you need to think about the way you structure it. So don't just do this because I've said it. Your table needs to communicate something, and if it looks really convoluted, you need to change its formatting until it works. Okay? So don't just do something because you're told. Make sure it's communicating what it needs to communicate. And once again, I will never read a table unless you tell me to read a table in the text. All right? So it must be referred to in the text. Here's a couple of examples. So this is, again, just research paper tables. You can see a lot of different things. I've got a central horizontal line that's breaking up the two groups. So the top group is a single search, the bottom is a double search. Not that that means anything to you, but those are two sets of data that are all the same for comparison, but I can break them up with a line. In this case, I've got a slightly bolder line on the top and bottom. That's not necessary, but you can do that if you want. You see all of the units are in the actual headings. And in this case, rather than say 1434000 in the table, I've actually put by 10 to the 6 at the top. That's a very common thing to do as well. Okay? But you can see that this is a lot of information and it's very clean and professional looking, and that's the sort of tables you want to be aiming for. The other thing is you can do things like comments. So, is my cursor showing up there? You see on this data point here, I've got this little dagger. Note, these results have deteriorated rapidly relating to blah, 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 blah. So if there's something that stands out or an anomaly or a particular data point that you want to highlight, you can actually use that type of technique as well. All right? So I don't expect you're going to be using something complicated like this for your current project, but this is a resource now that when you get to a point and go, oh, how should I format this table, you can pop back to these lecture slides and just have a look at a couple of examples, and hopefully that gets you started. Here's another one. Once again, instead of having a horizontal line, I've done a big bracket, but it's basically the same thing. It was just because I felt like making it look a bit fancy. Sometimes you can have dashes if there's no data points. That's about the best way to have it. Rather than have an empty space makes it harder to read the row, particularly when there's no horizontal lines in there. So if you just put a dash or a star or something whenever you don't have a data point, that makes it a bit clearer. You can absolutely put references in a table, like so, and so forth. And here's another example of that. Cool. Any questions on tables?
Yeah, on the empty space, do you have to note that on the dash, like on the bottom, you have to note that dash is empty?
If it's not immediately obvious, now a lot of the time you'll be writing these things up in a group, so you can hand your graph to your group member and say, look, is this clear or do I need to say something about it? And if a couple of them say, I don't know what you're doing, then you probably need to say something about it. If they say no, it's completely fine, then it's okay. So whether or not those empty spaces need to be defined really is a case by case kind of thing. In this particular circumstance, this is data from literature that I'm comparing my results for. This came from one paper and this came from another paper, and these guys didn't do these sizes or volume fractions or whatever, so that data wasn't available to compare to. I don't think I said anything about that because I just referred to comparing to data from this guy and this guy in the literature, and then someone reading it will go and get that paper and say, oh yeah, they only analysed those 4 data points or something like that. So in this circumstance I didn't, but there will be ones where it makes sense to do so. So just sort of use it wisely. All right, any other questions? Good. All right, we're on to graphs. Graphs are different to tables and they're different to figures. These are the 3 types of pictorial communication that you're likely to use in a report, okay? If you think of a different one, feel free to mention it and I'll comment on whether or not that's appropriate to go in a design report. Photos are figures, so photos count under figures. Graphs are basically kind of pictorial. It makes it really easy to interpret data a lot of the time, but they're very specific in so much as you have axes and data and that kind of stuff. It can be bar graphs, it can be line graphs. This is a Microsoft Word graph, all right? This is about as Microsoft Wordy as you want to go with graphs. Don't use their elaborate templates because once again they kind of look like Year 8 history reports to me. There's free software that I think, what's it called? Graph something or other? GraphPad. I'll send you a link. JCU has free graphing software that looks a lot more professional than this. It pretty much works like Excel, so if you do all your stuff in Excel and dump it into that, then you can really get some high quality graphs out of it. You don't need to do it for this report. I don't even know if you're going to have a graph for this report. But future, then that's useful to do, to have a high quality graph. But this type of formatting for MS Word is okay. Always should have a title at the top, unless it's really obvious in the caption that it doesn't need a title, but title is important. Always, 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 units and title on each of the axes. So don't give me an axes 1, 2, 3, 4 and don't tell me what 1, 2, 3 and 4 refer to. You absolutely must have both numbers and the explanation what it is and units. Okay? 1, 2, 3, 4, what? Every single graph that you ever do, it should have, unless it's non-dimensionalized, in which point you put a bracket, non-dimensional, end bracket, then every other circumstance you need to use the actual units. Okay? And you can put comments and various, you can see here, this is a rock field analysis they did. This was a giant big tank full of chemicals or something. And that tank was fatiguing in a very weird place. It was getting a crack on the bottom of it that was nowhere near loading or any particular complex geometry, and they were trying to work out what was happening. And so what they thought was that perhaps the vibration from the rest of the plant, I think this might be a mill or possibly it's QNI. But either way, the vibration from the plant was reasonably considerable there. They could actually sense it. And so what they did was vibration analysis of the actual component here. They put an accelerometer on it and recorded data over time. So that's why you've got time on the horizontal axis. And then they discovered that a blast that was happening elsewhere in the plant was actually causing a really big step change in that vibration. And repeated blasts were actually forces that weren't being taken into consideration if you just think of the resident vibration. And it was those that were starting to cause those fatigue failures. So they've identified that in the audit. They've done other analyses, and this is the graph that they put in that short report. and they've highlighted where the blast has been detected and at what time, and then in the report they've talked about what that actually means for the machine component, or the tank in this case. All right, so you can put extra data and comments, and you can even do zoomed in zones, and I think I'll show an example of that in a second. Yeah, you can see this. So this is a particular graph, and obviously this is pretty messy to see, so I've just done one of those blown out zoomed in zones, and it makes it a lot clearer, particularly because this is a full A4 page in a paper. And the same thing here, again, we've got a lot of data points, it's difficult to see, you expand it out. In this case, I didn't really need to do that, it was pretty obvious, so, you know, all under control. I don't mind if you use grids, so the grids or not. If it makes sense or looks good to do so, please do. Always, if you've got more than one line, you always need a key, because otherwise I have no idea what those lines are. And you don't say in the text, the blue line means this and the red line means that. Also, when you're doing lines, remember that a lot of the time this will be printed out in black and white. So blue line, red line, meaningless in black and white, so you need to have symbols that are distinct from one another and read individually as a black and white printout. That's a very important consideration for a figure. All right, and you can see here I've got my axis labelling. In this case I did it on the bottom and the right rather than bottom and the left. That's arbitrary. And I've got my captions and my time, and A, B and C and all of the information down here. Now in this case I didn't really need a title if you've got a caption. If you have a caption, and you should, then you can leave the title out if it's already being said in the caption, I think. A lot of the time it is a bit silly to say it twice. So I don't mind if it doesn't have a title, particularly if you've got multiple ones in a single figure. What else am I going to say? Oh, labelling. Labelling, it is labelled as a figure. All right, so the figures we talked about before, figure 1, 2 and 3, which are pictures, photos and so forth. Graphs or plots are generally within that figure labelling. So if you've got 3 figures before, this would be figure 4, etc. And then you explain what's being shown in the graph. And if you've got A, B and C, you explain what's being shown in each of the individual graphs. Cool? Here's another example. Once again, you can put multiple ones. So it didn't make any sense to me to have all 5 of these lines on a single graph because they're slightly different scale, and it kind of didn't make as much sense. It looked a bit clearer to have them separately, so you can do that. Make sure that when you read the graph, you understand exactly what's going on, and probably hand it to someone else and say, look, can you explain to me what's going on here? Because if something's missing, I need to add it. All right, so use each other to actually edit and improve your graphs, figures, tables, etc. Here's another one. I spent a lot of time on this one because I thought it looked pretty, so that was kind of the aim. But when you actually look at a graph and it catches your eye, now you're looking at the graph and you're absorbing the information. All right? So it's not just because it looks pretty, it's because that actually catches the reader. And in the particular context I was using it, which is a research paper, when someone downloads a research paper, they kind of just brush through and go, yeah, don't care, brush through, yeah, don't care, brush through, ooh. And then they start reading what you've actually done. And that's how you get people to cite your work and that kind of stuff. All right? So it catches people. The same thing with the design report. If you've got a really important thing, a really good quality figure is useful. Obviously this is a particular oil reservoir rock that I was doing those simulations on, and I had 4 different reservoir rock samples, and I've just thrown up some pictures. This one was very porous, this one was not porous at all, and you can see the 4 data points, and the blue is some, I think, experiments that were roughly where those data points had to be. So I was proving that yes, the results that I got are aligned with what they should be, and I've just added these things so that you have a bit of an idea of what dolomite looks like and how porous it is. But all of that information there catches your eye, and it tells you quite a bit just in that figure, which is very, very useful. Have you guys done log scales or log scales on figures? Has anyone read that? All right, write down for homework to look up log scales on graphs. So log as in a logarithm, log base 10. Log scales on graphs, because we will use them, and I've talked to second years in the past and been explaining things in terms of log graphs, and they've looked at me with a big quizzical look, having no idea what a log plot is. You guys will probably do it in PH 1005. but just get across it in a couple of different ways because log-log plots are important. It allows us to put a lot more information that's sensibly spaced out. So instead of, you see this? What is 10 to the 0? What's 10 to the power of 0? 1. What's 10 to the power of 1? What's 10 to the power of 2? 100, 1,000, 10,000, 100,000. Okay? So see, this is a non-linear axis. If it was linear, I'd be going 10, 20, 30, 40, 50. Yeah? So this is a log axis. And if you've got lots of data points in a particular small range and then spaced out data points, basically if your graph, where did I put that pen? If your graph looks like this, if you're going 1, 2, 3, 4, 5, if you do a log plot, basically you take each data point and you do a logarithm base 10 of it and you use that number in the graph, what you actually get is something that looks more like this. And so this range here, where it's just a flat line that means almost nothing to us here, we can actually start to interpret changes and differences and see that far more clearly if you expand that graph out and make those early data points more important. Right? That's why we use log axes in graphs. Every single graphing program, including Microsoft Excel, has a little checkbox that you can click to change that axis to log rather than just your standard scale. All right? You will use it a lot, so get across it now. It's as simple as reading a Wikipedia page, and then you'll be at least a little bit familiar with that. Cool? All right. So that's a lot of information on various different pictorial methods, but the main thing to take out of that in terms of your report is everything in there has to have captions, and try and use it as wisely as possible. Don't just dump a bunch of pictures in there. Think about what those pictures are actually doing in the context of your report. What are they telling me? How are you using them for communication? Because fundamentally, this is a communication, and you need to be able to actually say what they're doing, okay? And that's a formal project report. That's a type of writing that you will use as an engineer, but there are lots of other types of writing, okay? They might be lab journals, lab reports, progress reports and so forth. Project proposals, which is different to a project report because you're actually proposing to do something and you need to demonstrate that you understand things and lit review and things like that. Email. Email's a good one. I love emails. I probably got about 15 people saying workshop 1, group 2, etc. from last night. So you're about to get an email from me saying please resubmit with a workshop 2, group 2 or whatever. Hands up who proofreads emails once. Hands up who proofreads emails twice. Hands up who proofreads emails 3 times and then sends it and then reads the email again and go, fuck, a typo. Anyone? Because I do that. I do that all the time. I think I read every email I sent out after I send it out as well. Emails are critical, all right? You guys need to proofread emails as much as you proofread a design report, if not more, and you need to use good language in them, all right? Not necessarily the ones you send to me. You just need to get the workshop and group number in the subject heading right and make sure it's a PDF attachment. But emails are critical. If you work for a design consultancy and someone sends you an email saying, oh, I've got this picture, what do you think about it? You think it'll be all right or should I get you guys to do analysis on it? And you send an email saying, nah, looks like it should be right. That is engineering advice. And you just put yourself in a court case as soon as that fails. I guarantee you. Because any type of paperwork that comes out of a design firm or an engineering office is engineering advice, whether you like it or not. Even if you say at the top of the email, this isn't engineering advice, but it's engineering advice. Okay? So that's why you need to proofread emails. Consultancy firms, and I've had a lot to do with Rockfield over the years, so that's why I keep referencing them. Every single email that goes out of that company, the engineer proofreads it, a second engineer proofreads it, and then the certified practicing engineer casts his eye over it before they click send. Every email, other than personal communication between a particular, between 2 people. But if it's with a client, at least 3 sets of eyes, okay? Emails are so important and it's such a good such a benefit to you guys if you start practicing reading every single email before you click send, okay? Because you will need to do that as a professional engineer. It is a critical form of communication in today's age, and it's only getting more and more important. So start to use it correctly, and the correct way to use email is to proofread and absolutely make sure that it's correct in what you're saying, okay? And when you're submitting things like assignments and things, the last thing that you should do, did I say this the other day? I probably did, but the very last thing you should do before you click send or put it in a box is read the outline, and that sort of classifies as proofreading in the context where that's an email as well. So before you click send on every single workshop that you submit to me, read the outline once more and make sure you've put the right attachment in there, you've got the right subject heading, you've done the right things, and then click send, because then I won't have to send an email back to you saying, hey, you sent in the wrong thing, can you send it again, please? Cool? All right, resumes and application letters, that's a different form of communication, but you guys will need to get pretty familiar with that. Who's got a resume so far? Cool. We're actually going to do portfolios in a couple of weeks. And so what that is an online website that is your resume, but you can also put up things like SOLIDWORKS drawings and reports and that to actually demonstrate to employers, you know, how good you are. So we'll talk about that, but resumes are an important type of thing. Lit review we've talked a little bit about, but you can write one on its own, right? You'll do tutorials and exam scripts and various software and various other forms of writing that you might be involved in. All right. This is the structure that you're starting to get familiar with. So the structure that I've given you in terms of the briefs and the outline that you're using to lace those briefs together is kind of a short form of this, which is the structure of a long technical report. This is the structure that you would use for thesis, for example, when you get to fourth year. All right? This is a long technical or design report. You will have a title page, which is just basically the name of the report and the people involved, an executive summary or abstract. So that's a full page summary of all of the data points and all the important stuff. Then you'll have a list of contents, which I think I've put in your template. List of figures and glossary of terms you don't need in your stuff, but if you've got a 200-page report, it's useful to have a list of figures there just in case there's something you want to refer back to in the future. Because someone might see one of those railway sleeper steel things, whatever they're called, and go, oh, where was that figure? I want to see that. And rather than go through 200 pages, you just go to list the figure. There it is. Okay, cool. And you go back to that data. That's very useful in a report. Introduction, middle sections as it applies to your report, conclusions, recommendations, references and appendices. So this is the broad structure that you will use, okay? This is the structure that you're actually using for your design report, so everyone should be familiar with this. You must have a title page. I've given you a template. If you choose to write up your own Microsoft Word thing rather than use my template, I think even in the marking criteria you lose a couple of marks for that. I want you to use my Word file and just put your stuff into it, okay? It's already formatted like this. You won't stuff something up if you do that, okay? If you go and write your own and miss a chapter or something like that, then you're going to lose a lot of marks. But you've got executive summary, contents, introduction. The middle sections are lit review, design approach and design analysis. Then you've got conclusions and recommendations. We kind of group those sections, but if it's an actual design report or a design audit, then recommendations is the most important bit, yeah? If it's an audit and you're saying that thing's going to break, you need to replace it, that's a very long recommendation section to explain what you should replace it with, perhaps. And then references at the end. All right, introductions PDF, you got your research brief, your design proposal, analysis brief, and half of your testing brief and the final stuff sort of distributing over these two, but we've talked about that. Cool. All right, we've talked about referencing. Everyone should be comfortable with referencing. I think Brent found the IEEE referencing style is probably closest to what I use, which is you use a square box for a number and then you have the numbered references at the end like that, all right? So if you need an exact style to reference or to copy, IEEE, use that. Hands up if you know the difference between quoting, paraphrasing and plagiarising. Sort of. Yeah, there's a distinction between them. Quoting is obviously you take what someone else has written and you throw it straight in there. And when you do that, it's no good just putting it in there and then having a reference in your bibliography. If you don't refer to the bibliography, it doesn't count. Same as figures, tables and graphs. All right? And when you quote someone, you need to reference it right there and then, and it needs to be in actual quotation marks and italic and offset, such that you're highlighting a giant big, I have taken this from someone, but I'm not trying to steal it. Honestly, officer, I'm not. You move it there and you put all of that information right there and then, and that's correct. Reference from or quoted from page something right there, okay? A quote is anything, if you've cut and pasted the language, you must reference it like that, all right? Paraphrasing is if someone's written a paragraph and you just rewrite their paragraph, or someone's written a sentence and you rewrite their sentence, that's paraphrasing and you need to reference it because it's their ideas, it's just your words. All right? So you need to reference that right there where you do it as well. It's no good just to take a Wikipedia page and then reword it and put it in your document and claim it as yours because that is academic misconduct basically. You need to actually identify when you're paraphrasing and make sure you have a reference to acknowledge the original writer for their ideas. And then plagiarising is flat out just cutting, pasting stuff and sticking it in your document and not telling me who you got it from. All right? I've had an example in the past where someone took a list straight off Wikipedia, threw it into a section and then had a reference at the very end of Wikipedia page something or other, and that's all they did. And I identified that as plagiarism and we went through the actual mechanisms until we realised that he put it at the end there, but that's not good enough. That's still plagiarising. You need to say, I got this from here, when you put something like that in, okay? Yeah, if it's in a table, you put it in the caption. That's right. If you've taken a graph offline or a photo, then you say from 6. Or something like that in the caption of the graph, photo, figure, whatever. And then in the text you can say blah blah blah, we did something or other, refer to figure 1 from, boom, and put the reference there again, just to be sure, just to make sure. That's the best way, and I'll recommend that to anyone that does a thesis. That's how when I edit a thesis, I make sure they're doing that. All right? So be very clear on the language that you're using because we will pick it up because oftentimes we've read the same literature and papers and things that you guys have, and if we read something and go, wow, that seems really familiar, you'll get pinged for it. Actually, that was what it was. It was a whole bunch of text, and the person had cut and pasted in with all of the highlighting to the links in it still in the formatting that they've cut in. And so, like, we looked at it and went, I've seen that before. Where is that? And looked it straight up. It's just a page there. So that was a very lazy example of plagiarising. But make sure that if you're going to cut and paste text that you quote it. It's a quote. Obviously you can't do a whole design report as a quote. You won't get any marks because that's not your work. But the library has a libguide on referencing, which is very good, and included in that is how to reference or what is the difference between plagiarising and, paraphrasing and all that kind of stuff. Lots of tools for you to use there, so use that resource. The last one is this Harvard generator. I don't know how much use it'll be to you, but if you've got a website, you put the website in there and you click generate, and it'll pull a bit of information out of the metadata and so forth of that web page. Now, if you don't know how to pull metadata out of a page, that's useful because you'll get a last updated date, so you can use a date, and if there's any authors stated or anything like that, it'll strip that information out as well. Sorry? So I'll give you an example. So if we put up the JCU website maybe, and we just do that, it won't give you an elaborate reference, but it'll just give you some information and a kind of style. So home, JCU Australia 2016, online available at. So this online available at is probably the best way to put a URL in a reference. All right, so in brackets online, available at, and then the URL. And any sort of author information, date or company. So I wouldn't use all of that. I would probably say I'd use this to then write my reference. So I would say JCU homepage 2016 online available at. All right? But it's giving you the information there. You just need to restructure it into something that makes sense for your reference. So that's very different to just going www.jcu.com.au or .edu.au or whatever. In your references, you have more information than that, so you can use more information than that. So what web page like that, 2016, and then the available online, and that becomes a URL, but it's a really professional way of demonstrating a URL in a reference for a document. Okay, rather than just put the URL there. So that's just the last thing that I'll say about referencing. It makes it a bit easier to use URLs because you will be using a lot of them in this report and the next, I imagine, because a lot of the information is fairly general. Cool? All right, what have I got left? Anything? No, that's us. So any questions on that? No? Cool. Excellent. So everyone's going to use very high quality figures in their design report. Let me know if you have any questions or clarifications on that. Otherwise, enjoy the rest of your week.